Good morning, everybody. Fergus Dolan here from NALA. You're very welcome to our webinar this morning on algebra. The title is Algebra, a Balancing Act, Strategies to Help Students to Approach Algebra Effectively. And we're delighted to have Robert O'Mahony. Robert is a numeracy and ESOL tutor with Cork ETB. Morning, Robert.
Good morning, Fergus, and good morning, everybody else. It's great to see so many people connected today.
Okay, so this is our third Maths Week webinar. We've got one tomorrow at 2 o'clock and then one on Friday morning at 11. There's still places on any of them. If you would like to book, you can just look on the NALA website. So I'll hand you over to Robert. All the best, Robert.
So as I said, it's great to see all you connected today as well. And I'm sure you've been thinking about the title of this webinar, Algebra, a Balancing Act, Strategies to Help Students to Approach Algebra Effectively. Don't we all want to improve in the way that we teach algebra, approach algebra in order to help our students to engage with it, isn't it? Algebra, as we know, as numeracy tutors or maths teachers, algebra can be a very powerful tool, can't it? We know that we can observe things, we can generalize, we can model situations. And algebra, it can be encountered at all levels. And I put it there twice for emphasis. It can be encountered at all levels, whether the very basic or when we get to using algebraic notation, isn't it? So the very first task that I want you all to do is I'd like you to either type this URL into your web browser, or you can use your phone there to scan the QR code. And up there, you're going to get the possibility to put in your answer to this question. What do your students think of when they hear the word algebra? Okay, what have been your experiences with your students when they hear the word algebra? And we'll be able to see your answers come up here then once you have entered them in. Okay, and if you're having any issues, you can put it into the text box or unmute yourself, and then you'll be able to. I suppose I should go back here a second for people to be able to access. Okay. So we can put that into our web browser or scan the QR code. I'll leave it there for another few minutes. Okay, I'm starting to see answers. That's great. Okay, we'll actually share the screen there between the two of them as well. Okay. Perfect. Okay. So we're starting to see there. I can't do that. Oh my goodness, the X's and the Y's. Don't want to engage. I don't use the word. So feel free to continue to add in there if you haven't done so already. But what we're starting to see is that the experiences that you've had with your students haven't been exactly positive, have they? They've been more negative than positive. And for various reasons, isn't it? They perceive it to be complicated. They perceive it to be something that they cannot access. What's the point in using this? I'm never going to use it in real life, and so on, and so on, and so on, isn't it? So we'll just make this bigger again, and we'll go back to slideshow. Perfect. Brilliant. So these are some of the comments that I've seen as well myself. Okay, so common student observations. This one was from a student called Kate. I used to always wonder, well, how do you add letters? How do the letters come in? But I didn't know how it worked at all. No one really explained. Again, it ties in with what you've experienced from your students. And Ben, I think what made it so complicated for me was that I had to understand the X and the Y. We had that in the answer garden. And I think that always seems so confusing, and how to get the full understanding of the X and the Y. Other than that, it just seemed like, oh my God, what is this all about really? Now, you might think that these two students were maybe in secondary school, but these were adults in their 40s. These were adults that were in a numeracy class in their 40s, and they had these observations and these feelings towards algebra. So they've never been able to get over that since they were in secondary school, have they? So then how can we help our students to maybe see it as in a more positive light? So really, it's all about the thinking, isn't it? If they can understand the thinking, then they can access it. So when it comes to algebra, we want to look for the structure to make sense of the situation. We want to generalize, don't mind the typo, I'll change that before giving it to you, beyond the specific by using symbols for variable quantities. Of course, then we want to represent it in various different ways, whether it be actually algebraically or with tables or with graphs. And we want to use reasoning, logical reasoning as well. If we're able to use this sequence of algebraic thinking, then we'll be able to access the algebra. Obviously, then we want to know what the strategies are. So when it comes to algebra, we can incorporate that into many strands of our course, can't we? We can take simple problems and expand them by changing the conditions. So for example, imagine there's a sum in the class and it says, I went to the shop and bought 4 cartons of orange juice and 2 bottles of 7-Up. 4 cartons of orange juice and 2 bottles of 7-Up. Perfect. They find the answer, they write that down and all the rest of it. And then you change it up. Okay, and you say, how about you bought 5 bottles of 7-Up and 2 cartons of orange juice? How would that be different? What would have happened with the money? So we want to maybe add some sort of complication to our problems in order to help them to think algebraically. Although they won't be seeing A, B, C, X, Y, Z, it is a form of algebraic thinking, isn't it? And as they're doing these questions, we want to be asking probing questions. How did you do that? Why did you do that? Could you do that a different way? Helping them to start thinking and start reasoning. And again, we don't want to focus just on getting the answer, do we? We want to focus on the relationships between the numbers. We want to see patterns in problems. And then eventually we want to be able to use symbols for generalizing as well. It's important to focus on procedures, and we want to use repetition with that as well to help them to do it. But we want to have less emphasis on routine procedures and more emphasis on the deeper understanding of what's happening, don't we? And when we're using our questions with them, the sums that we have, we want to see and address the misconceptions that they may have. A very common one is, for example, the equal to sign, isn't it? For a lot of our students, the equal to sign is, I need to get the answer. But of course, we know that the equal to sign, the left must be balanced with the right. And that concept evades so many of our students right up until their adult years as well, isn't it? So I have a question here for you, okay? So we want to look and identify the structure. There may be many different ways to tackle this, okay? So this is where we're going to ask you, please, to put into the chat what the answer would be, but not only what the answer would be, how did you get to that answer? And what was your way of thinking, okay? This is very common financial math question. It's something that they may come across in real life. So how would you tackle that question and why? Okay, I'll give you a few minutes. If you want to open your mic, please do. If you prefer to put it into the chat, that would be absolutely no problem as well. But we'd like to get the most of you to add in something of that, okay? So take your pencil and pen and your paper and whatever you do there to calculate, and we look forward to seeing your answers in the chat function there. Okay, so Mairead, you're saying divide 0.24 into 3. Very good, very good. So that might be a bit of calculator work. 300 cents divided by 24. Very good. Excellent. €3 divided by 24 is equal to 0.125, rounded to 12 bananas. Very good. Excellent. 300 divided by 24. Well done. Thank you so much, Tom, Siobhan, Katrina, Caroline, and Mairead for that as well. Brilliant. Okay, so what about if we approached it in this way? Let me just fix that. Okay, what about if we approached it in this way? Well, we know that 24 is 1 less than 25. 25 is a nice even number to deal with when we're talking about 100 units, isn't it? 100 cents. So 24 is equal to 25 minus 1. Nobody in the class would dispute that, would they? That's fairly obvious. And of course, then, if we were to multiply 12 by 24, like most of you there have said that the answer is 12, okay, 12 by 24, we're going to be able to calculate by using the distributive property of mathematics. So again, this is another place where you could stop and do a mini lesson on the distributive law of mathematics. 12 by 25 is that, 12 by 1 is that, 300 minus 12 is €2.88. Okay, so you will use buy 12 bananas and you will come up to €2.88 there. Okay, so the distributive laws of that would work very well for you. Okay, brilliant, excellent. I like your reasoning. So now we have generalizing an algebra puzzle. Okay, so I would like everybody to take a pen and a pen out, and I'd like you to follow along with me with this puzzle and see what you get from it. Okay, so here we go. I want you to pick any number at all, any number. This is something that you could use with your students, maybe to introduce the topic of algebra, to revise the topic of algebra, to get them to think algebraically. So pick a number. I want you now to add 10 to it. Okay, I want you to add 10 to it. I now want you to multiply all of that by 4. And then add 60. Divide that number by 2, or divide it in half. Subtract it by 20. Divide it in half again. And subtract your original number from that. Okay? Pick a number, add 10, multiply by 4, add 60, divide in half, subtract 20, divide in half, and subtract your original number. Okay? So I won't say what the answer is. We'll go back a second. Okay? We'll come off of that. Okay. So we'll stop sharing for a second. And what I'd like you to do now is, Fergus, if we can open the breakout rooms, I'd like you to discuss what you got with each other. And I would like you to put an algebraic background to it if you can, okay? I'd like you to think how could you incorporate algebraic thinking into this formula, into this puzzle, and we will be able to come back in a few minutes' time and see what you have thought about it.
How long will I give them in the breakout room?
You give them 3 minutes.
3 minutes, okay. Okay. Robert, just John Brown, oh, that's great, he went into one. John Brown was having trouble logging in, you know, his name kept coming up, so he's finally gone into one.
Okay, so I'm going to put that into the chat now. Copy, although they probably will have already done it, but
Okay.
oh, save chat. And what we want to do there now is share that again. Okay, so we went through this guy here, and I'm sure all of you got the answer of 15. Okay, so what I'd like you to do there now is I'd like you to either chat in the box or turn on your microphone and tell us, how can you get this puzzle to jump onto the topic of algebra? How could we make this into an algebraic way of thinking? Does anybody have something they could say from the breakout room that they were in? Okay, either typing or saying there. Okay. PEMDAS. Okay, PEMDAS. Siobhan, could you maybe expand on that, if you would, with your own time there? And of course, we welcome anybody else as well to give their observations on it.
Could you unmute Siobhan, please?
I'm sorry, I answered in chat. I just found I did it step by step as the instruction gave, and I did get 15. But in our breakout room, I wasn't sure what we were supposed to do, so I thought the only way I could solve it was to use brackets where necessary, following the BODMAS or the BEDMAS rule. I don't know, am I right or wrong on that?
Okay, that's perfect. No, that's one way to look at it. I suppose when we're thinking algebraically, aren't we? We want to use letters to represent something that we don't know. So would anybody be able to tell me which step we would be representing with a letter, something that we don't know?
X, just throw X's, pick a number X.
Very good. Pick a number X. Excellent. And then we can just do the steps with X involved in it, isn't it? Very good, Siobhan. Thank you so much for unmuting. So as we can see here on our table, what's happening algebraically with that sum, as you said, Siobhan, and everybody else, I'm sure you were thinking the same thing. We can get the students to think, to say to themselves, look, if you're picking a number, you don't know it. So we need to associate that with something that we don't know. X is generally what it is, but it can be any letter of the alphabet. And then you go through the process, okay, X plus 10, no bother. 4 multiplied into that, 4x plus 40, add your 60, 4x plus 10, divided by 2, 2x plus 50, take away 20, 2x plus 30, divided by 2, x plus 15, and take away your original number, which was x, you end up with 15. So that means that no matter whether you chose a negative number, a small number, or a very large number at the very start in dealing with very, very big numbers, it's all going to be the same because it's an algebraic way of dealing with something. Now, that's a nice exercise maybe to start some students with an algebraic way of thinking and to maybe map on. So this is like, let's say, common knowledge, common sense, maybe you're just adding numbers, taking numbers, multiplying numbers. But then, of course, we can introduce the topic of algebra or revise the topic of algebra using this table format as well, with the English versus the algebra on either side and getting them to reason algebraically there as well. And of course, then we could give them different puzzles with all sorts of different adding and taking and multiplying and dividing, and getting them to do a similar process and seeing, are they able to go through it in an algebraic format as well? Okay, so that was an interesting puzzle there that we could use with our students. Okay, so here we have a true or false question. Okay, I want you to think for a moment. And again, please use the text box or unmute. True or false? Which ones are true and which ones are false? Okay, so that's my first question. Which ones are true and which ones are false? What would you say? Again, you can use the chat function, or you can unmute. One or the other is perfectly fine. Okay, so if we could get you to analyze there, which one is true, which ones are true, and which ones are false. Okay, so we're saying 2, 3, 4, 5, you're saying is true, and 1 and 6 are false. Okay, well done, excellent, very good. Obviously, if you tidy up the left and you tidy up the right, you'll be able to see that they are not true, isn't it? But again, some of my students, Mairead is saying, would read them as 1.2 plus 5 is equal to 7 plus 1, etc. 1 multiplied by 2 plus 5. Maybe, Mairead, you could expand on what you're saying there. 1.2 plus 5 is equal to 7 plus 1.
They'd read that as 1.2,
Question. Okay. First
2.2,
question.
3.4, 4.7.
I
They wouldn't see the space.
They wouldn't see the space. Okay. So, Mairead, would you have a suggestion as to avoid that confusion with your class then?
I'd use letters.
Letters would be better. Okay. Perfect. No bother. Good idea. Okay. So, as we said, number 1 and number 6 are false. Brilliant. But again, we want to think algebraically. We want to map algebra onto this very common sense maths, isn't it? To include this in any level that we have. So we can see here the algebra properties that we will be going through with students when we are starting off the topic of algebra. We know that any number plus 0 is that number. We know that a plus b is the same as b plus a. We know that b multiplied by a is the same as a multiplied by b. And we know that a squared has to be a by itself. So even without doing the maths then, if they were able to practice and get better at these algebra properties, that information, that way of thinking would help them to answer these questions in a much faster format, isn't it? And of course, your students might not be there where they see those algebra properties. In fact, more than likely, they are not there seeing those algebra properties. But if we take the time to constantly feed back the algebraic properties to any of our maths that we're doing with our students, any of our numeracy, we can see that it is possible to introduce them to the topic of algebra even before or even after we have taught it in various different formats as well. Okay, so here we have a false answer, isn't it? 2 plus 5 is equal to 7 plus 1. Could anybody tell me, maybe to extend this mathematical conversation with our students, what could you ask them to, if you ask them, what could you change here in order to make the left-hand side equal to the right-hand side, in order to balance the equation? Maybe you can either speak out loud or write in the chat function, what would you do to change it so that it is balanced? Okay, so Caroline there is saying add 1 to the right-hand side. 2 plus 5 is 7. 7 plus 1 plus 1. To the right-hand side. Maybe it's to the left-hand side? No, 2 plus 5 is 7. 7 plus 1 is 8. So take 1 from the right-hand side, maybe. Yeah. If you took 1 from the right-hand side, it would be balanced. Yeah. If you took 1 from the right-hand side, it would be balanced. Conversely, then, if you added 1 to the left-hand side, it would be balanced, isn't it? Exactly. So extending their way of thinking all the time and getting them to see that that equal to sign is about a balancing scale there as well, isn't it? Okay, we could also help them to understand that not only can we add and take from the left-hand side or right-hand side, we could change symbols altogether. Yeah, 2 is less than 5. Well, actually, if I were to change it all together, sorry about that there. We want to share that. Perfect. That guy there, isn't it? We want to be moving that guy over here. Perfect. Excellent. So we can see here that if we changed the equal to sign to a less than, the left-hand side would now equate to the right-hand side, isn't it? Using inequality. So again, adding another element into our maths lesson for revision purposes, of course, as well. Okay, so when it comes to most people's way of learning, a visual element is always helpful. Of course, you have visual learners that really need it, but all of us cope very well with visual models, don't we? Researchers have found that when students learn maths with visual models, students' math performance improved significantly. So in this part of our webinar, what we're going to be doing is introducing visual models to tackle algebraic ways of thinking, okay? And visual model, obviously, as it says, visual, helps the students to actually see the rule, okay? What you do to one side of the equation, you have to do to the other side of the equation. So not only are we getting into being able to go from common sense questions over to algebraic ways of thinking, we're also helping them to really see the true meaning of the equal to sign as well. Okay, so this is a funny picture. I got this picture from a very interesting resource on Desmos called One-Step Equations Balancing the Hanger. So that's something that you could look into yourself, maybe incorporate in your teaching. It has other resources there in that Desmos file. But my question to you is, what's happening in this picture and what observations can you make about it? Again, you can use the chat box or you can unmute. And thank you so much in advance for everybody to write as much as you can, and as many people as possible as well to take your observations here.
They're both the,
John, do you have something to say there?
yeah, they're both the same quantities. Sorry.
Okay, so they're both the same quantities. So you're saying that the pink side and the blue side, they have the same quantities, John, is it?
Yeah, they're different color. And the blue one is going up if you're correlating it. The blue one's going up to the side. The other one is straight.
Okay, John, thanks for that. Okay, thank you so much. Siobhan is saying their weight in sock 3, so sock 3, the first blue one makes it way heavier. There must be something weighing it down. The lower blue sock is lighter or smaller. Very good, excellent. So I suppose because that wooden element, that wooden part, that line there is not at the same level, we could say this is not balanced, isn't it? This is not balanced. And as Siobhan said there must be a weight in that third sock or the first blue sock. So we could say that the left-hand side here definitely does not balance with the right-hand side, okay? Now again, that's an interesting resource that I took from Desmos. Feel free to look it up and use that in your own teaching. There's other files there that you could use too. But this idea about hanger diagrams is going to be very useful for a visual way of introducing, revising, talking about the idea of algebra, okay? So again, here now, we have this diagram. Maybe it looks similar to the socks for you, maybe it looks different to the socks for you. But again, without me saying anything, what are your observations, okay? So again, you can unmute or you can put your comments into the chat function. Okay, thank you in advance for typing it in there for us. If you could just give us your observations about maybe left-hand side versus right-hand side. Okay, So Siobhan has added up the W's on the left. She's seen that there are 5 W's. She's seen that there's 3 W's on the right, and we're saying 5W plus 2 on the left and 3W plus 8 on the right. So Siobhan has made an equation out of it. Very good, excellent. Brendan, you're saying that W is heavier than 1. Okay, W must be heavier than 1 because we can only see 2 ones on the left, but there's several on the right. Very, very good. Okay, and this is something that we can use with our students. We want to see what they're thinking, how they're reasoning. Are they completely off track from the way we want them to think, or do they just need a slight push in the right direction to get them to think algebraically as well? Of course, it's brilliant. You know, we as maths teachers, we are prone to thinking mathematically, algebraically, and the first thing that I saw as well, as Siobhan did, was the equation. But again, we want to maybe make this into a visual experience for our learners as well, don't we? So what if we were to take away similar things from the left-hand side to the right-hand side to simplify this down for ourselves and make the equation a bit simpler for them, okay? So we can see that there are 3 W's on the right, there's 3 W's on the left, so we can just cross them out. We're done with them, yeah? Technically speaking, you've taken exactly the same thing away from the left as the right, so it's all still balanced. It should still be balanced. Brilliant. Now that I've shown you this, I'm sure you're aware of what I'm going to take away next. There are no more W's on the right, but they do have other things in common, isn't it? They have 2 ones on the left. There's several ones on the right. So let's take away 2 ones on the left and 2 ones on the right. And now, all of a sudden, for our students that are maybe finding it difficult to think algebraically, that would look at 5W plus 2 is equal to 3W plus 8, like, what is that about? Now it's been reduced down to something that is more manageable, isn't it? So we can see there now that 2W is equal to 6. And very simply, most of our students are going to be able to just half that to get what the answer is, isn't it? W is equal to 3. So this idea of using a hanger diagram is very, very, very useful in helping our students to think algebraically, okay? It's all a balancing act in the end, isn't it? As the title of this webinar says. We want it all to balance the left-hand side with the right-hand side, and we want to hit those algebraic lesson goals as well, okay? Perfect. So we have another one there. Now that you can see how it works, right? Maybe you can have a think about how you would approach this and how that could work maybe visually as well. Fergus, are the Desmos maths resources free? Yes, they are. Yes, they are. They're all there. When you get this PowerPoint, you can just copy and paste the title or type it into your Google search engine and it will come up for you, okay? They're all free. So if you can think about, of course, you're welcome to write down an equation, but also how could you approach this in a visual format as well, do you think? Again, thank you so much for writing your comments into the chat box. We appreciate it. And anybody that wants to unmute also is very welcome. Okay, so what value for W keeps the hanger balanced? How would we go about this question?
The 2 1s.
The 2 1s, you're saying, is it? Oh, so the visual way, John, is it?
Yeah, if you were to take the 2 1s from the left side, and then you have the 2 corresponding ones as from the other side, then it would help the equation.
Very good, very good. So first of all, mathematically speaking, you could possibly add up what's there on the left and add up what's there on the right, isn't it? And you're saying that 2 plus W is equal to 5, W plus 2 is equal to 5, okay? And that's algebraically perfectly correct. We can get our students to think that way as well. But as John said, if we were to take away what's common on the left and what's common on the right, this sum could be easily solved for our students that have a predisposition maybe to think negatively about algebra, isn't it? So we can see here the answer is perfectly W is equal to 1, 2, 3, W is equal to 3. Perfect, excellent. Of course, then we want to, chop and change. We want to approach things in several different fashions because our students will be exposed to several different fashions of approaching things themselves as well, isn't it? So we put the same thing up there now, and imagine that we were to give them a multiple choice question, okay? This is a very much, well, we can still use visual, they can still use it visually, but this is maybe another added way of thinking, isn't it? Why is A wrong or right? Why is B wrong or right? Okay. So of course they could go through the visual method. They could get W plus 2 is equal to 1, 2, 3, 4, 5. Okay, so we're saying that B is the correct answer. But then we're going to say, Siobhan, can you please tell us why A is not the right answer? Mairead, could you please tell us why C is not the right answer? John, could you please tell us why W is not the right answer? And you can see how they are thinking. You can see where you need to continue to maybe put more effort or put more material or put more focus in your lessons, because you'll be able to get some feedback from them as well as to the way that they are thinking, okay? So just another format of putting the question is always very handy as well, to get them to be thinking algebraically and to be reasoning on what they are learning and what they are doing. Okay, so here we are. Again, if you can scan that QR code, and if you cannot scan, if you do not have another device, you can type this URL into your web browser. And I would like you to draw with the pen and paper in real life here. I want you to draw a hanger diagram for the equation that you see on the screen. And then when you're ready and you've done that, you can scan the QR code or put in the URL, and it will bring up Padlet for you. I'm going to split the screen there now in a minute, and we'll be able to see what you've drawn, but it's all anonymous. Nobody will be able to know who has drawn what. Okay, so perfect. So let me split the screen here, and here is our Padlet. Okay, so you should be seeing this when you scan the QR code or when you type this into your web browser. Okay, I'll give you a few minutes to come up with an idea of a hanger diagram yourself to maybe tackle this algebraic equation. And we look forward to seeing what you have done there, okay? Okay, has everybody been able to access the Padlet? Okay, what we can do there is we can put the URL into the chat. Okay, we put that URL into the chat. And maybe what we could do, Fergus, if that's okay, if we could open a breakout room and we can we're able to share ideas with one another then. If that's okay, Fergus.
Yep.
And if we could put about 8 minutes on that.
Yep.
Before we get into the breakout room, when you go into the breakout room, what I want you to do is I want you to agree on somebody to share their observations, anything that they've observed. And of course, we'll be able to share your actual drawings then as well